Hello! We are Group 4, and our project is called DragonKeep. Now what is DragonKeep? Well, it's a tool for managing the over-the-table riffraff of playing Dungeons & Dragons, such as character sheets and party management. Okay, now we have a quick demo of our app. Transition.
Hi, welcome to DragonKeep Web Edition. Let's make a new account to explore the application. Alright, let's make a user named John. We're going to fill in some basic information, the email first, and a password. And we're going to create our brand new account. So first you're going to be met with your main dashboard. Here you've got your Groups tab and your Characters tab, where you're going to see all of your groups and characters stored after you've created them. So on the bottom right, on the Groups tab, you can click on your dial menu and create a new group. Awesome, let's make the Jedi Juniors group. Just click on the Create Group button here, and we see our group populates immediately in our Groups tab, owned by John. So let's create a character. Same thing, we're going to click the dial menu on the bottom right and create a character. Great, Baby Yoda. And we're going to easily fill in some of these fields to store our important information. All right, we've got some appearance here, some appearance information. We know he's small and green and adorable. All right, let's fill in some statistics and round this character out. Hit points, very small amount of hit points I think here. What sort of abilities does Baby Yoda have? Lots of charisma, and maybe a little bit of intelligence, and some skills. Oh, absolutely. Definitely some persuasion, and maybe a little arcana. And features. All right, so what features? Well, we do know that he's part of a carnivorous race. Awesome. Let's create this character. So Baby Yoda, we're going to go back to that button on the bottom right and create our new character. Baby Yoda is going to populate immediately on the dashboard. You can click and view your character and change any of the details that you need. Chaotic, neutral, and save. And there you go. There is your introduction to DragonKeep.
Okay, now we'll go over our major choices and outcomes. So to build our app, we decided to use Flutter, which is Google's UI toolkit for building natively compiled apps for mobile, web, and desktop. We chose Flutter for a couple of reasons. First, so that we would have a single code base, and since the code can compile into different native languages. So the second reason is there's high customization for designing the UI, and the next reason is we just wanted to learn something new because a majority of us have never developed Flutter apps before. Lastly, we chose Flutter because there's plenty of documentation on the Flutter website and other online communities. So as a result of using Flutter, we found that coding the UI was straightforward and the documentation from the Flutter website helped. However, since most of us were new to Flutter, most of the development time was spent learning the basics of Flutter, learning the language, which is Dart, and we were unfamiliar with it, and we spent a long time refactoring our code into block architecture, which I'll talk about later. And despite these difficulties, we're still able to successfully develop a cross-platform app that worked on Android, iOS, and web browsers. So in terms of our server, we chose AWS Lambda, which is a serverless compute service provided by Amazon AWS. Instead of managing servers, Lambda lets you upload code that runs automatically as a response to events such as HTTP requests via Amazon API Gateway, which is another technology, but I'll talk about it later. We chose AWS Lambda over AWS EC2 mainly because we wanted to spend less time managing and provisioning the environment, which is required in EC2. So in addition, we were interested in learning about serverless backend products, and there was a lot of documentation to allow us to explore Lambda. So as a result of using AWS Lambda, we found that Lambda was lightweight and reliable. Therefore, we were able to get our server up and running fast. However, an aspect of Lambda that gave us headaches was the permission system because it was confusing at first, but we eventually figured it out. Another issue that Lambda caused us was propagating live state changes. It wasn't able to do it properly, for example, updating a character sheet. So we were forced to come up with a non-efficient solution to fix it. And for our database, we chose DynamoDB, which is a NoSQL database. We chose DynamoDB for a few reasons. Namely, it has a similar use case to our application. We felt that the depth storage provided by a non-relational database would keep our database slimmer. And because there's so much information contained within a single character sheet, we thought it would be ideal to reference all that information quickly with one query. Also, we felt that non-relational databases would be good to learn. So the pros of using DynamoDB were the ease of use in creating the table itself, as well as being able to store all the data relevant to the app in a single table. Unlike in a relational DB, where everything is spread across multiple different tables. Furthermore, the schemaless nature of DynamoDB means that changing the structure of each individual data item is very easy, so we were able to add and remove fields without having to change the entire back end. However, one of DynamoDB's downsides is not having the same amount of control over queries as relational DBs. For instance, it's not really possible to do a join in DynamoDB, at least not through the default set of functions. And DynamoDB also requires knowing the data access patterns of the app before creating the database if you want to take advantage of all the features. So another technology we chose to use was the Amazon API Gateway, which I mentioned before, which is a service that allows us to create simple APIs. Amazon API Gateway appealed to us because it would allow us to experiment with building RESTful APIs. Also, we chose Lambda and DynamoDB, so there is an easy integration with Amazon API Gateway. Specifically, it was built for easy communication to Lambda and also our database. So as a result of using Amazon API Gateway, we successfully implemented a RESTful API. In addition, having a RESTful API allowed us to have a separation of concerns between our app and AWS Lambda. However, the tough part was trying to navigate and understand Amazon's permission system once again. So for continuous delivery, we chose AWS Code Pipeline, which helps automate release pipelines. Since we were using AWS services, we had seamless integration with the AWS Code Pipeline. And as a result of using AWS Code Pipeline, we were able to automatically pull changes from our master branch, automatically complete tests, compile updates, and deploy the release. So for our app architecture, we chose Block, which stands for Business Logic Component. So to briefly explain, UI widgets send events to the block with syncs, and widgets are notified by the block with streams, and the business logic is implemented by the block. We chose Block because we wanted to keep the code clean and organized, and business logic would be easier to test. Since Block normally contains a lot of complicated code with streams and syncs, we were able to use a Flutter package called block package to simplify the code. So as a result of using block architecture, we encountered some roadblocks because it had a steep learning curve. So we spent a long time learning about block and refactoring some of our existing code that wasn't in block already. So in addition, the Flutter block package had frequent updates, and the tutorials didn't really apply to complex apps, so it was tough to apply it to our project. Another problem was that our code consisted mostly of default widgets, and block fits better with custom widgets, so we had to wrap the default ones, which made our UI code a bit messy. Although blocks reduced the amount of test code, it was still difficult to figure out how to write the tests, and it required a bit of research. But despite these difficulties, because of block, we maintained a separation of concerns between the UI and the logic. Alright, thank you for watching, and have a nice day.